But 3I Atlas is different. The original tracking period was supposed to end in late January. That deadline passed, we are now in early February. And multiple observatories are still watching this object. They are still taking measurements. They are still collecting data. I know this because I have colleagues at these facilities. They have told me the tracking continues. And when I asked why, I got vague answers. Interesting answers. Answers that suggest something worth watching is happening. I want to be clear about something before we go further. I am not suggesting anything dramatic. I am not claiming aliens or secret conspiracies. What I am saying is this. When scientists quietly extend observations beyond the planned timeline, it means they are seeing something that warrants continued attention, something that does not fit expectations, and that alone is worth discussing. The history of 3I Atlas is already unusual. It was discovered in August of last year. A telescope in Hawaii spotted it first. Right away, astronomers knew it was special. Its path showed it came from interstellar space. It was traveling too fast to be bound by our sun's gravity. It would pass through our solar system once and never return. Only the third such object we have ever confirmed. That made it worth studying. From August through October, many telescopes watched it. Ground-based observatories, space telescopes, radio dishes, they gathered data from every angle, every wavelength, visible light, infrared, ultraviolet, radio waves. The coverage was extensive. We wanted to learn everything we could before it got too far away. Because opportunities like this are rare. Interstellar objects do not visit often. At its closest approach to the Sun in October, 3I Atlas was about 90 million miles away. That is roughly the same distance as Earth's orbit. Not particularly close, but close enough for good observations. The object appeared to be about half a mile wide. Maybe a bit more, difficult to measure exactly because it was so far away, but definitely large enough to study properly. Initial observations showed no tail, no cloud of gas around it. That was interesting. Most comets show activity when they get near the sun. Ice turns to gas, material streams off, you see a coma and a tail. But 3I Atlas looked clean, just a point of light, like an asteroid. That suggested it might be rocky, or perhaps its ice was buried deep, covered by a layer of dust. The original plan was to track it until it became too faint. That would happen naturally as it moved away, farther from the sun. Farther from Earth, the light would dim. Eventually, even our best telescopes would lose sight of it. Based on calculations, that would occur sometime in late January. After that, the object would be gone, lost in the darkness of space. Never to be seen again, but January passed, and the observations continued. I first noticed this on January 28th. I was reviewing tracking schedules, seeing what objects were being observed, and I saw 3I Atlas still on the list. That surprised me. It should have been dropped by then. So I made some inquiries. I contacted colleagues at observatories. I asked what was happening. The responses were interesting. One astronomer at a facility in Chile told me they had received a request to continue observations if possible. The request came from NASA's Jet Propulsion Laboratory. It asked for any additional data they could gather. No detailed explanation. Just a request for continued tracking. The Chilean observatory agreed. They had some available telescope time, so they kept watching. Another colleague at an observatory in Australia said the same thing. They also received a request. This one came from the European Space Agency, again asking for continued observations, again with minimal explanation, just a note that the object remained of scientific interest. The Australian team complied. They adjusted their schedule to include additional tracking time. A third contact at a radio telescope facility mentioned similar instructions. They were asked to keep monitoring the radio emissions from the region, to watch for any signals, any changes, anything unusual. The instruction came through official channels from their parent organization with a priority tag that suggested importance. Now let me tell you what this means. When multiple organizations request continued observations, it means something. Scientists do not waste telescope time. Telescope time is precious, expensive, heavily competed for. Every hour costs money. Every observation must be justified. So when NASA and ESA both ask for continued tracking of a single object, that object must be interesting. There must be a reason. A scientific reason worth the cost and effort. I started asking more questions. What were they seeing? What made this object worth extended observation? The answers I got were careful, measured. People did not want to speculate. But patterns emerged, common themes. Things that multiple sources mentioned independently. First, the object's brightness was not decreasing as expected. Let me explain. As an object moves away from the sun, it gets darker. Less sunlight hits it, less light reflects back to us. The brightness drops. This happens predictably. You can calculate how bright an object should be at any given distance. It is basic physics, but 3I Atlas was not following this pattern exactly. It was staying slightly brighter than predictions suggested. Not by much, just a few percent, but enough to be noticeable. Second, there were variations in the light, small changes in brightness over time. These variations suggested the object was rotating, spinning on its axis. As it spun, different surfaces faced us. Some surfaces were brighter, some were darker. This created a pattern, a light curve. And that light curve was unusual. It did not match what you typically see from natural objects. The pattern was too regular, too consistent, almost like clockwork. Third, radio observations detected something faint, very faint, a signal at a specific frequency. It was right at the edge of detectability, so weak that some measurements showed it and others did not. But it was there. Multiple observations confirmed it. And the frequency was interesting. It was not a common natural frequency, not one you would expect from random emissions. It was specific, narrow, almost like a carrier wave. Now I must be very careful here. I am not saying this signal is artificial. I am not claiming we have detected alien technology. What I am saying is that the signal is unusual, unusual enough to warrant investigation, unusual enough to justify continued observation. That is all, nothing more, just something that does not fit the normal pattern. Let me tell you about natural radio emissions. Many objects in space emit radio waves. Stars do, planets do, comets do, gas clouds do. These emissions happen naturally. They come from charged particles, from magnetic fields, from chemical reactions. They are random, broad spectrum, spread across many frequencies. That is the signature of natural emissions. Wide and messy, but occasionally you see narrow emissions, focused at specific frequencies. This can happen naturally too. Under certain conditions, when electrons spiral in magnetic fields, they emit at specific frequencies. When molecules in space absorb and re-emit radiation, they do so at characteristic wavelengths. So narrow emissions are not automatically artificial. They can be natural, but they are less common, and they require specific conditions. The signal from 3I Atlas was narrow, very narrow, and it was steady. Not fluctuating wildly, not appearing and disappearing randomly, just a constant low-level emission. That steadiness is interesting. Natural emissions usually vary more. They pulse, they flicker, they change with conditions. But this signal was stable, like something being transmitted continuously. I spoke with a radio astronomer about this, someone I have known for many years. I trust their judgment. They told me the signal was being analyzed. Multiple teams were looking at it, trying to understand its origin. Some thought it might be interference, radio noise from Earth, satellites, electronics. That happens sometimes. Earthly signals can contaminate astronomical observations, but the teams were checking for that, cross-referencing with known interference sources, and so far, no match had been found. Another possibility was maser emission. A maser is like a laser, but with radio waves instead of light. They occur naturally in space, in regions with specific molecules. Water masers, hydroxyl masers. They emit at characteristic frequencies. Could 3I Atlas be producing maser emission? Possibly, but it would require the right molecules, the right conditions, and no other interstellar object had shown this before. So it would be unusual, but not impossible. The third possibility was the one nobody wanted to say out loud. The possibility that the signal was not natural, that it was produced by technology, by something designed, built, operated. This is the idea that gets attention, that generates excitement and controversy, and also skepticism, because extraordinary claims require extraordinary evidence, and we did not have that evidence. Not yet. just a weak signal that did not fit easily into natural categories. I want to emphasize something. Science works by testing ideas, by eliminating possibilities. You start with the most likely explanations, the natural ones, the conventional ones. You test them. If they do not fit, you move to less likely explanations. You keep going until you find something that works, or until you run out of conventional explanations. Only then do you consider unconventional ideas. That is where we are now. Testing conventional explanations, seeing if any fit. The extended tracking period gives scientists time to gather more data, to test more hypotheses. If the signal is interference, more observations will confirm that. If it is a natural maser, detailed analysis will show it. If it is something else, well, we will need more data to know for sure. That is why the tracking continues. To answer these questions, to understand what we are seeing, there is another aspect to this. Something I learned from a colleague at NASA. The tracking extension was not just about the radio signal. There was also interest in the object's motion, its trajectory. Earlier observations had shown small deviations, tiny changes in the expected path. Nothing dramatic, just minor adjustments that did not quite match predictions. These could be explained by outgassing, gas jetting from the surface, pushing the object slightly, but there was no visible evidence of outgassing. No coma, no tail, so what was causing the deviations? This is a puzzle that has come up before with Oumuamua, the first interstellar object. It also showed unexpected acceleration, small pushes that were hard to explain. Scientists debated for years about what caused it. Some said outgassing, even if invisible. Others suggested more exotic ideas. The debate continues, and now 3I Atlas might be showing similar behavior. That makes it worth studying carefully. The extended observations are looking at this, measuring the trajectory with high precision, looking for patterns, for clues about what might be causing the deviations. Is it outgassing? Is it radiation pressure? Is it something else? The data will help answer these questions, but it takes time. Time to gather enough measurements, time to analyze them properly. I find myself thinking about the bigger picture, about what this means for our understanding of interstellar objects. We have only confirmed 3 so far: Oumuamua, Comet Borisov, and now 3I Atlas. That is a very small sample, not enough to draw broad conclusions. Each one teaches us something new, shows us something unexpected. Oumuamua was cigar-shaped, fast-moving, with mysterious acceleration. Borisov was more typical, a comet with a tail, behaving as expected. And now 3I Atlas is presenting new puzzles, a possible radio signal, unexplained motion. What will the fourth one show us? The fifth? Each object adds to our knowledge, challenges our assumptions. There is a hypothesis that interstellar objects are common, that thousands pass through our solar system every year. Most go undetected, too small, too faint, too fast. We only see the rare ones that come close enough, that are large enough, that happen to be spotted by our surveys. If this hypothesis is correct, then space between stars is full of wandering objects, rocks, ice balls, maybe other things, all traveling through the galaxy, occasionally passing through star systems like ours. Some of these objects might be ancient, formed billions of years ago, ejected from their home systems, wandering ever since. They carry information about distant places, about other star systems, about conditions far from our sun. Every one we study is a messenger, bringing data from regions we cannot easily visit. That makes them valuable, worth the effort to observe and analyze. But there is another possibility, one that is more speculative, more controversial. Some researchers have suggested that a small fraction of interstellar objects might not be natural. They might be artificial, probes sent by other civilizations, or debris from ancient technologies, or vessels traveling between stars. This idea is not mainstream. Most scientists are skeptical, but it is not impossible, and it is worth considering, worth testing. Because if even one such object exists, it would be the most important discovery in human history. I am not saying 3I Atlas is artificial. I am not making that claim. But I am saying that the unusual observations warrant continued study. That the extended tracking makes sense, that we should not dismiss unusual data just because it is uncomfortable. Science advances by investigating anomalies, by taking seriously the things that do not fit. That is how discoveries happen. Let me tell you about the process moving forward. The tracking will continue as long as the object remains detectable. That might be weeks, maybe months. It depends on how faint it gets. At some point, even the largest telescopes will lose it. It will drop below the detection threshold. When that happens, observations will end. But until then, data will be gathered. Every possible measurement will be taken. Every instrument that can contribute will be used. That data will be analyzed carefully. Multiple teams will work on it, using different methods, different approaches. They will look for patterns, for explanations, for anything that helps make sense of the observations. Some analyses will be published, shared with the scientific community. Others might remain unpublished. Preliminary results that need more work. That is normal. That is how science operates. Eventually, we will have answers, or at least better understanding. We will know if the radio signal is real, if it has a natural explanation. We will understand the trajectory deviations, whether they are normal or unusual. We will piece together a complete picture of what 3i Atlas is, what it tells us, what it means. That picture might be surprising. It might be mundane. We do not know yet. That is what makes this interesting. I want to share something personal. I have been studying space for over 40 years. I have seen many discoveries, many surprising findings. Some lived up to their initial promise, others turned out to be less dramatic than first thought. That is the nature of science. You follow the data wherever it leads. Sometimes it leads to breakthroughs, sometimes to dead ends. Both are valuable, both teach us something. With 3i Atlas, I feel we are in that uncertain phase, where data is interesting but incomplete, where conclusions are premature, where patience is required. The extended tracking tells me that people with expertise see something worth investigating. That is encouraging. It suggests the story is not over, that more chapters remain to be written. I encourage you to follow this story, to pay attention to developments, because something is happening. We do not fully understand it yet, but it is worth watching, worth learning about. Whether it turns out to be natural or something more unusual, it will teach us about the universe, about the objects that travel between stars, about the possibilities that exist beyond our solar system. If you found this information interesting, please share it. Talk about it with others, help spread awareness of this developing story. Science benefits from public interest, from people paying attention, from support for the research that makes discoveries possible. Your interest matters. Your engagement helps. Subscribe to this channel if you want updates. As more information becomes available, I will share it. I will explain what it means, what implications it has. This is a developing situation. New data comes in regularly, and I will do my best to keep you informed, to present the facts, to discuss the possibilities, to maintain the careful balance between excitement and skepticism that good science requires. Remember, space is full of mysteries. Objects like 3i Atlas remind us how much we still have to learn, how much remains unknown. That is not a weakness, that is an opportunity, a chance to expand our knowledge, to push the boundaries of understanding, to discover new things about the cosmos we inhabit. The fact that tracking continues tells us the story is not finished. That scientists see value in continued observation, that alone is significant. It means we are watching something that matters, something that could change our understanding, or at least add another piece to the puzzle. And that is worth our attention, worth our time, worth the resources being devoted to it. Thank you for staying with me through this. I know it raises more questions than answers, but that is where we are right now, in the phase of investigation, of data gathering, of careful analysis. The answers will come. They always do. It just takes time and patience and the willingness to follow the evidence wherever it leads. Keep looking up, keep asking questions, keep learning about the universe around us. Because that universe is vast, full of wonders, full of mysteries, and every now and then, something comes along that reminds us just how much we still have to discover. 3i Atlas might be one of those things. Time will tell. But for now, we watch, we measure, we analyze, and we wait to see what the data reveals. Until next time.